the last lecture, we have discussed about the introduction of language, what is language and what is grammar, and how to construct a language and equivalent grammar, that is the production rules. Now, we will show more problems regarding the language and grammar equivalence. Equivalence means if a language is given to you, you have to construct the rule set of rules for that particular language, and vice versa also. That means, if a grammar is given to you, from that grammar you have to construct the language. So, that is the language and grammar equivalence, and we will come up with some more problems and respective solutions. Suppose one set of problem is given, that is find grammars that generates the sets of all strings with exactly one A. All strings with at least one A all strings with no more than 3A all strings with at least 3A. So, let us start with the first one, that is all string with exactly 1 A. Means that first of all, it is already told that the alphabets or the elements of that particular language is A and B only. So, if all the strings that contains only exactly one A means it must contains an A, B may be there, B may not be there. So, we can consider the strings as minimum string as omega 1 is A, omega 2 may be A B, omega 3 may be B A B, omega 4 is B B A B, means exactly one A will be there, and after that B may be there, B may not be there, or maybe there are more than one B. So, how to ensure that there will be at least exactly one A will be there and there may be any number of B? Means that as it consists of any number of A, any number of B. So, it should be like this, S equal to S B, or another point is that B may be at any positions, that also we have to take care of. So, let us write it as A, S equal to A, and as it is exactly 1 A. So, A must be there, and capital A means it will be replaced by B, and A will be stopped by lambda. We can write it like this. So, let us explain it how it is coming, that exactly A is ensuring that exactly one A must be there, and this A are the position of the B, any number of B may be there. If I need the B before A, that case this A will be replaced by A B, and if I need B after A, that case this capital A will be replaced by A B. and how many number of b is required, that will be ensured by the number of times this a will be replaced by. And if I do not need any b either before a or after a, that case this a will be replaced by lambda and this a will also be replaced by lambda. And if I need b before a and after a, in both the cases, that case this a will be replaced by a b and this a will be replaced by a b. So, this productions, the productions for this particular problem is S 2 a and sorry a to a b to lambda. Now, let us consider the next problem. Now, instead of exactly 1 a, it is consisting of at least 1 a must be there. So, earlier cases, as there is no number of b is mentioned. So, the number of b may be 0, may be 1 or may be more than 1. But in this case at least 1 a must be there, and after that any number of a may be there or any number of b may be there. So, to ensure at least 1 a, what we have to write? That means, let us first check that what are the strings may be there. The strings may be it may be omega 1 equal to a, that means at least 1 a is there, and there may be any no b also, and it may be b a b, or it may be omega 3 b a b, or it may be omega 4 equal to b a b a, like this. Means that at least 1 a must have to be ensured. Now, how to do this one? So, as there should be at least 1 a is there, so s will be replaced by a, and after that this a will be replaced by a to a b or a to a slash lambda. Now, already I told that at least 1 a, it is ensuring at least 1 a, and before a there may be any combination of any number of a, or there may be any occurrence of a or b. So, it will be ensured by replacing this a with a b or a based on my requirement, and I may require also any number of a or b after this a. So, that will also be ensured by replacing this a with a b or a. So, the solution for this problem will be S 2 a and a 2 a b slash a or lambda. Now, these two problems are solved. Now, let us consider that all string with no more than 3 a, that means only 3 a will be there, means that if I consider the string as a, if I consider the string as 2 a, if I consider the string as 3 a, that is this one is omega 1, omega 2 and omega 3, all will be accepted, and any there is no restriction for b. So, there may be any number of b in between this 2 a, there may be any number of b in this between this 3 a, or before a 3 a there may be b, or after 3 a there may be b. So, it may be like this also, it may be b a b, or it may be b a b a b, or it may be b a b a b a b a, but I cannot write 4 a b. So, it is not accepted. So, for a, it is the restriction is that at least 3 no more than 3 a will be there. So, 2 a is also accepted, 1 a is also accepted, even no a is also accepted, but for the b there may be any number of b. So, how it can be ensured? Let us see. So, if I consider a, if I consider 2a, if I consider 3a, but 4a will not be accepted. So, how can I write this one? So, if I write s equals to triple a, that should be accepted, right, but in between this 3a, b may be at any positions. So, I should write it by keeping some space in between them. So, let us write it like this: s equal to a or s equal to double a or s equal to single a, and in between this 3a there may be a capital. Why I am writing this capital A? To replace this a with b if it is required. Now, this a will be this a will be replaced by a b or lambda. Now, how can I ensure that there should not be any a? So, to ensure that there is no a, no b, because it is written that no more than 3 a must be there. So, this a will be replaced by a also. So, when I do not require any a, that case this s will be replaced by a and a will be replaced by lambda. That is it. Now, what should be the solution for the last problem? That all string with at least 3 a. At least 3 a means it must be 3 a and there may be more than 3 a. That means the minimum string omega 1 will be 3 a, and in between this 3 a there may be any number of b or there may not be any b. Omega 2 it may be like this also, or omega 3 it may be b a. So, there may be any combinations, but at least 3 a must be there. So, how to ensure that at least 3 a will be there? So, let us replace this s with a, and in between this a, if I require any number of b, that case this a will be replaced by a b or lambda. So, this is ensuring that at least 3 a will come. So, hope it is clear to everybody that how to solve if you need to understand the jargon of words. Here first problem it is written that at least one a is there, one a must be there and there may be any number of in the first problem it is written that exactly one a is there. No more than 1 a, not more than not less than 1 a. The second problem it is written that at least 1 a must be there, there may be any number of a more than that, and no, and the third problem it is written that no more than 3 a, and the fourth problem at least 3 a should be there. So, let us consider the next problem. Now, before coming to the next problem, we need to say another one thing, that is that what is star closure and what is positive closure. Star closure and positive closure. Already we told that the alphabet sigma represented the alphabet and it consists of the non-empty finite set of symbols, that is a and b. If and if we write that sigma star means that apart from a and b, it consists of lambda also. And if we write sigma plus or a b plus, means that it consists of a and b, there is no lambda. So, this one is called star closure and this one is called positive closure. Now, we can write this one as like this: star closure sigma plus equal to sigma star minus lambda, or sometimes it is written that only no star no plus, only written that a b. It means that by default value this one is star closure, means that if nothing is mentioned, it is star closure. Now, come back to the next problem, that is the equivalence. As we have told that the equivalence of grammar and language, means that earlier we have shown that the language is there and how to prepare the grammar. Now, we are giving one example, that grammar is given to you and what should be its language. So, let us see the simple give a simple grammar. Consider this grammar. And what should be its language. S to A to BS and S to lambda. These three productions are there. So, in this kind of problem, you have to derivate all the productions to find out what are the strings are generating, and after that you have to find out a common sequence or common pattern out of these strings, and from that you have to generate your language. So, let us, what is your start symbol? My start symbol is S to A. Now, A can be replaced by B S, right, and if I replace this S with A again, this one, then I will get A B A. If I replace this one, then I will get A B S. So, every time I am replacing, I am getting a new string symbol. So, if I the next two productions, I must get A B S. The next three production I must get A B S. So, in the first two replacement I am getting A B only. In the next two replacement I am getting A B, next two replacement I am getting A B S. So, if I replace this S with lambda, then I must get only A B, sorry, I must get only A B, then sorry, A B or A B like this. So, can I say in a general form the grammar must be LG equal to A B whole n, where n greater than equal to 0. Now, how can I get the null string then n equal to, if I put n equal to 0, I must get 0 only, right. So, that case instead of replacing this S with A, I must replace this S with lambda, I will get the null string. Now, let us solve another problem, that is the grammar is given to you and I have to find out the respective language. S to A to B to A. Now, try to solve in the same manner. If I, as S is the start symbol, replacing S with A. Now, this A with B, then I must get BA. Now, B with A again, what a confusing thing. Again this A must be replaced by B, then it will become BAA. Now, this BA with AA. So, in first two replacement I am getting, instead of a I am getting 2a. In the next two replacement I am getting 3a. I hope in the next two replacement I must get 4a. But how to stop this one, because there is no terminating string is there. So, it will continuously producing a new string with a variable. That means the string is never going to stop anywhere. So, this types of language is called infinite language. Infinite language. The definition of language is, infinite language is that the language which cannot be stopped at the runtime with some terminating string. So, until and unless a terminating string will be provided to you, it will continuously producing a sentential form. Now, again, what is sentential form? Sentential form. Sentential form is the combination of variable and terminal symbol. Sentential form is a combination of variable and so, if I write like this a, that means it consists of the combination of variable and terminal symbol, it is a sentential form, and if it consists only terminal symbol, that case it is called sentence, not sentential form. So, hope you understand what is the difference between sentence and sentential form. Now, coming to the next problem. So, n greater than equal to 0 and m greater than n. So, the minimum value of n is 0. So, if I put n equal to 0, at least one b must be there. If the minimum value of n equal to 0, then m may be 1, 2, 3, anything. If n equal to 1, then m must be 2, 3, 4, anything. If n equal to 2, then m must be 3, 4, 5, any values. Right. That means, if only whether a is there or not, b must be 1b, 2b, 3b, like this. If the value of a is 1, that case the b must be 2, 3, like this. If the value of a is 2, then b must be any values. Sorry, it must be the minimum value of b is 3 or more. Sorry, 3, the value of b is 3, value of b is 4, like this. Now, how to solve this problem? So, one thing is clear, that at least one b must be there, and after that there may be equal number of a, equal number of b, or there may be any number of b. So, let us write that s equal to a b. means this confirms that at least one b must come, and after that equal number of a equal number of b is coming, or any number of b may comes. And if I don't anything, that means at least one b is there, and I want to stop this one, then stop it with lambda. So this in this way. So tell me any one of the strings. Suppose if I consider this string 2a and 3b, which is which must be satisfied by this language. So how to get this language? So replace s with ab, at least one b is coming, and after that replace this a with aab, and again replace this a with a and triple b, and after that replace this s with a lambda triple b. That means I am getting a triple b. So let us consider another problem. Lg equal to an b twice n greater than equal to 0. Already I think I have discussed this problem, so I am not going to discuss this one. In the last lecture I have already discussed this one. So let us consider the next one. The next problem tells me that Lg equal to an plus 2 bn n greater than equal to 1. So my minimum value of n equal to 1, that case I must get at least 3a 1b, and after that 4a 2b, or 5a 3b. So let us first make it sure that at least one a and equal number of a and equal number of b will be there, and after that any apart from this 2a must be there, 2a must be there. So it is very simple, replace this s with asb, which is confirming that equal number of a and equal number of b is coming, and then stop the s with not with only a, it must be stopped with 3a and 1b, because my minimum value is at least 3a and 1b, because if I put the value of n equal to 1, then I must get this production. Now consider the next problem, that is Lg equal to an p n minus 3, where n greater than equal to 3. So consider the minimum value of n equal to 3, then it will be a3 b0, that means 3a must be there, and if n equal to 4, then it will be a4 b1, that means 4a 1b. If n equal to 5, then it will be a5 b2, that means 5a 2b, like this. Now here also we may get that equal number of a and equal number of b's are coming, and apart from this 3a is extra. So how to ensure this one? So replace the s with asb, and then how to stop s? What is the what is the minimum value? That is 3a. Stop s with 3a. Now let us come up with some more complex problems for the grammar. Let us consider a grammar, and let us consider a language, and what should be the grammar for this particular language. What 3 equal to 0. Now we know that omega is any string. Suppose if I consider omega, and in this case I forgot to write another thing is that here sigma equal to a only, no b. So, and here sigma a means it is star closure, that means a and lambda both must be there, and any number of a will be there, either it may be 1a or it may be 2a or it may be 3a, but we have to check that what is the mod of omega. Mod of omega in this case is 1, and if I make a modulo division, that means 1 mod 3, 1 modulo division 3 means 1 must be divided with 3, and what should be its remainder. So, if I divide 1 with 3, the remainder is what? In this case the remainder is 1 and it is not equal to 0. So, this one will not be a part of this language, and in the next case mod omega is 2 and 2 mod 3 is means what is the remainder. In this case the remainder is 2. So, this language is also not be accepted by this, this string is also not accepted by this language, and if I consider mod omega equal to 3 and 3 mod 3, that means what should be the remainder. If I divide 3 with 3, the remainder will be 0. So, this will be accepted. So, it is very simple, that means if it is the number of a is 3, it will be accepted. If the number of a is 4, that case my what should be my remainder? A is 4, then mod omega mod 3, that means 4 mod 3, right, 4 mod 3, and what should be my remainder? My remainder in this case is 1. So, it will not be accepted. And so, similarly, if the number of a is 5, then 5 mod 3 is 2. So, it will not be accepted. If the number of a is 6, then 6 mod 3 is 0, remainder is 0. So, it should be integral multiple of 3. It must be the number of a must be integral multiple of 3, or in simple words, number of a must be 3, number of a must be 6, 9, 12, like this, and in each of the cases the remainder will be 0. So, how to ensure this one? LG equal to, I am writing this problem again, omega where mod omega mod 3 equal to 0. So, if I replace this s with, as there is no concept of b, so I just can replace this s with triple a s, and if I want to stop this one, then s will be stopped with lambda. Similarly, if another problem is given, LG equal to omega where mod omega mod 3 greater than 0. Greater than 0 means if the number of a means if it is a only, then mod omega equal to 1 and 1 mod 3 is 1. So, it must be accepted. If the number of a is 2, then mod omega equal to 2 and 2 mod 3 it is 2. So, it must be accepted. If a equal to 3, mod omega is 3 and 3 mod 3 is 0. So, it will not be accepted. So, it is just opposite the previous problem, that means it will accept 1a, it will accept 2a, but it will not accept 3a. Similarly, it will not it will accept 4a, it will accept 5a, but it will not accept 6a. So, it must not be the integral multiple of 3, it must not be integral multiple of 3. So, how to solve this problem? So, let us consider the here we have found out that there are two types of strings we are getting, where one is a where the remainder is 1. Okay. One is a where the remainder is 1, another is 2a where the another is 2a, where the remainder is 2, and 3 is not accepted, 3a is not accepted. Right. Now, what about the 4a? In case of 4a, what is my remainder? 1, and in case of 5a, what is my remainder? 2, and in case of 6a, it is obviously not accepted, and in case of 7a, my remainder is 1. In case of 8a, remainder is 2. In case of 9a, the remainder, it is not accepted. Okay. So, let us see now how to construct the grammar for this one. So, in each of the cases, look at here, it must be one thing is common, that there must be integral multiple of 3 and one extra a, means that in this case when a single a is there, we can write this one as 1 a plus 3 into 0. In this case, I can write it as 1 plus 3 into 1, and in this case I can write it as 1 plus 3 into 2. Here I can write this one as 2 plus 3 into 0. Here I can write it as 2 plus 3 into 1. Here I can write it as 2 plus 3 into 2, means that in this case it is integral multiple of 3 with 1 extra a. In this case it is integral multiple of 3 with 2 extra a, and as it is not be accepted, so I do not have to consider this one. So, can I replace this one as s will be, instead of replacing with 3 a s, I will replace it with two types of s. One is s1, another is s2. s1 will provide me the integral multiple of s with 1 extra a, and s2 will provide me integral multiple of a 3a with 2 extra a. So, s1 will be replaced by triple a s1, and it will be stopped with a, and s2 will be replaced by triple a s2 with 2a. So, when I need a single a, I will replace this s with s1, and after that s1 will be replaced by triple a s1. When I need to stop it this one, I will stop it with a. When I need this combination, so I will replace s with s2, and then s2 will be replaced by triple a s2, and s2 will be stopped with double a. Hope it is a little bit tricky, but it is conceptual. Hope you understand this one.